Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to Amazon's Simple Queue Service, or SQS, a fully managed message queuing service that enables decoupled, scalable, and resilient communication between distributed application components. We'll explore why message queues are critical in modern architectures, walk through the core concepts and features of SQS, and show you how to get started with creating and working with queues. Let's get started. Before we dive into Amazon SQS, it's important to first understand why message queues are such a critical component in modern architectures. At the core, message queues help decouple system components. Instead of tightly linking a producer and a consumer together, a queue allows each to operate independently, improving modularity and simplifying development and scaling. Message queues also enable asynchronous processing, allowing systems to remain responsive by offloading long-running tasks. Rather than blocking users while a process completes, the work is queued and processed separately, improving overall performance and user experience. In event-driven architectures, queues are the backbone, allowing services to react to events in near real time without the need for tight integration. Queues also help manage variable workloads. When traffic spikes, say during a flash sale or a marketing campaign, a queue can absorb the sudden surge, buffering messages until consumers catch up and preventing back-end systems from being overwhelmed. Fault tolerance is another key advantage. If a consumer service becomes unavailable, messages remain safely stored in the queue until the service recovers, reducing the risk of data loss and improving the overall resilience of the system. Reliability features like message durability, retries, and dead letter queues ensure that every message is processed correctly, even in the face of transient failures. From a scalability perspective, queues allow each part of the system to scale independently. You can scale out consumers horizontally based on the volume of messages in the queue without affecting the producer side. Finally, queues allow for prioritization and work segregation. Different queues can handle different workloads or priorities, helping allocate resources efficiently and meet business requirements. SQS is a fully managed message queuing service. That means you don't have to worry about setting up or maintaining any queuing infrastructure. No servers to provision, patch, or scale. AWS takes care of the heavy lifting, so you can focus entirely on building and running your applications. SQS provides two types of queues. Standard queues are designed for maximum throughput. For use cases that demand strict order and exactly once processing, SQS offers FIFO queues. One of the biggest strengths of SQS is its scalability. The service elastically scales to handle virtually any volume of messages, automatically growing with your application's needs without manual intervention. Whether you are dealing with hundreds of messages per day or millions per second, SQS can handle it. Reliability is also built in. SQS ensures messages are delivered at least once and provides robust features like visibility timeouts and dead letter queues to manage failures gracefully and minimize message loss. Security is a first-class citizen in SQS. You can control who can send and receive messages using AWS Identity and Access Management policies. Messages are encrypted at rest using AWS Key Management Service and protected in transit with HTTPS, ensuring your data remains secure end-to-end. Finally, SQS integrates seamlessly with many AWS services. Whether you're triggering a Lambda function, coordinating workflows with step functions, or handling back-end processing with ECS or EC2, SQS acts as a powerful backbone for building distributed, event-driven applications. In the illustration, a single producer sends messages to an SQS queue, which are then independently processed by three separate consumers, demonstrating how SQS enables true decoupling between components at the core of the architecture. Let's now explore the core building blocks of Amazon SQS, the foundational elements that make this service work. At the heart of SQS are queues. A queue is a temporary repository that holds messages until they are processed. SQS provides two types: standard queues, which support high throughput with best effort ordering and at least once delivery, and FIFO queues, which guarantee that messages are processed exactly once in the exact order they were sent. Next, we have messages. the actual units of data that flow through the system. Each message can carry up to 256 kilobytes of content and may contain structured data like JSON, XML, or just plain text. In addition to the body, messages can also include attributes and metadata to support routing and processing decisions. Producers are the components of your application that send messages into the queue. These could be microservices, backend systems, or user-triggered processes. The key point is that producers are decoupled. They simply drop messages into the queue without needing to know how or when they'll be processed. On the other end are the consumers. These are services or applications that pull the queue, retrieve messages, process them, and then delete them. Consumers can scale horizontally, working in parallel to handle increased throughput, and they don't need to coordinate with producers. Finally, one of the most important mechanisms in SQS is the visibility timeout. When a message is retrieved by a consumer, it becomes temporarily invisible to other consumers. This gives the consumer time to process it. If the message isn't deleted within the timeout window, it reappears in the queue, ensuring it's not lost and can be retried. Now let's talk about SQS producers, the components responsible for sending messages to the queue. One of the key benefits of SQS is that producers are completely independent of consumers. A producer simply needs to know which queue to send the message to. It doesn't need to know who will process it, when it will be processed, or even how it will be processed. This decoupling provides incredible flexibility and allows systems to evolve independently. To optimize performance and reduce costs, SQS allows producers to send messages in batches, up to 10 messages in a single API call. Batching reduces the overhead of frequent network requests and can significantly improve throughput, especially in high-volume systems. When sending a message, producers can also attach message attributes, key value pairs that carry additional metadata alongside the main message body. Attributes can be used for things like routing decisions, prioritization, or passing contextual information to the consumers without modifying the message payload itself. In real-world applications, network interruptions and transient errors are a reality. Well-designed producers include retry logic to handle these scenarios gracefully. If a send attempt fails temporarily, producers can automatically retry based on configured backoff strategies, ensuring that critical messages aren't lost due to short-lived issues. Another powerful feature available to producers is per-message delivery delay. Producers can set a delay timer on individual messages, controlling exactly when the message becomes available to consumers. This is useful for deferred processing scenarios like scheduling notifications or delayed workflows. Finally, for workflows requiring strict order and exactly once processing, producers can leverage FIFO queue semantics. When sending messages to a FIFO queue, producers can specify a message group ID to maintain strict ordering within that group and use deduplication IDs to prevent accidental reprocessing of duplicate messages. Let's now look into the role of SQS consumers, the components responsible for retrieving and processing messages from the queue. In Amazon SQS, consumers must actively pull the queue to receive messages. SQS is a pull-based system. It doesn't push messages to consumers automatically. Polling can be done either using short polling, which immediately returns even if no messages are available, or long polling, which waits for messages to arrive, reducing the number of empty responses and API costs. Once a consumer retrieves a message, it must explicitly delete that message after successful processing. Retrieval alone does not remove the message from the queue. This approach ensures reliability. If processing fails, the message isn't lost and can be retried by another consumer. SQS naturally supports parallel processing. Multiple consumers can pull and retrieve messages from the same queue simultaneously. This allows you to horizontally scale your processing layer based on workload, whether that's spinning up more EC2 instances, scaling out containers, or adding serverless workers. An important aspect consumers must manage is the visibility timeout. When a message is retrieved, it becomes invisible to other consumers for a defined period. The consumer must complete processing and delete the message within this window. If it fails or times out, the message becomes visible again and can be reprocessed, ensuring no message is lost. Consumers can also take advantage of message attributes. These key value pairs can be used to filter, prioritize, or route messages, allowing consumers to implement more intelligent and efficient processing logic tailored to business needs. Finally, Amazon SQS integrates seamlessly with AWS Lambda. Standard and FIFO queues can trigger Lambda functions automatically, enabling fully serverless, event-driven architectures without manual polling, perfect for lightweight, reactive processing workflows. Amazon SQS standard queues are one of the two main types of queues available in SQS. Standard queues are designed for high throughput. They can handle an almost unlimited number of transactions per second, making them ideal for applications that need to process vast amounts of data quickly and efficiently. One important characteristic of standard queues is at least once delivery. SQS guarantees that every message will be delivered at least once, but in some cases, a message might be delivered more than once. That's why it's important for consumers to be idempotent, able to handle duplicate messages without unintended side effects. When it comes to ordering, standard queues provide best effort ordering. SQS tries to preserve the order of messages, but it doesn't guarantee it. If your application requires strict message sequencing, you would need to use FIFO queues instead. However, for most large-scale distributed applications, best effort ordering is often sufficient. Another major advantage is that standard queues are highly scalable. As your application load increases, SQS automatically scales to accommodate the traffic without requiring any manual setup, tuning, or pre-provisioning. Standard queues are also designed for low latency. Once a message is sent, it usually becomes available for consumption within milliseconds, ensuring that applications can react to new data almost instantly. To further optimize operations, standard queues support message batching. You can send, receive, or delete up to 10 messages in a single batch operation. This reduces API overhead, improves throughput, and helps lower overall costs. Finally, standard queues are fault-tolerant and highly durable. Messages are redundantly stored across multiple AWS availability zones, ensuring that they are protected against infrastructure failures and are reliably available whenever needed. FIFO queues in Amazon SQS is a powerful option when your application demands strict ordering and exactly once message delivery. Unlike standard queues, FIFO queues guarantee exactly once processing. This means a message will be delivered and processed only once, never more than once, eliminating the need for complex deduplication logic in your consumers. As the name implies, FIFO queues preserve first-in, first-out ordering. Messages are received in the exact order in which they were sent, which is essential for many transactional workflows. This ordering is preserved using a concept called message group ID. Messages with the same message group ID are processed sequentially, in strict order. However, messages in different groups can be processed in parallel, enabling concurrency while still preserving order where needed. It's important to note that FIFO queues have lower default throughput compared to standard queues, typically up to 300 messages per second without batching and up to 3,000 messages per second when using batching. But AWS offers an optional high throughput mode for FIFO queues, which significantly increases message per second limits while still maintaining ordering guarantees within each group. FIFO queues also support deduplication to prevent the same message from being sent more than once accidentally. You can use a message deduplication ID to explicitly identify duplicates, or rely on content-based deduplication, where SQS automatically detects and filters out duplicate messages based on their content. These features make FIFO queues especially well suited for use cases that require strict consistency and sequencing, such as financial transactions, inventory management, or order processing systems, where the correctness of operations depends on the precise order of events. With FIFO queues, Amazon SQS gives you the tools to build robust, deterministic workflows where order and precision are non-negotiable. Amazon SQS has a message size limit of 256 kilobytes, which is sufficient for many use cases. But what if your application needs to send much larger payloads, such as large JSON documents, media metadata, or data blobs? That's where the SQS Extended Client Library comes into play. The SQS Extended Client Library enables your application to send and receive messages that exceed the 256 KB limit by leveraging Amazon S3. Instead of trying to cram a large payload into a single SQS message, the extended client automatically stores the message content in Amazon S3 and sends a lightweight reference, essentially a pointer, through SQS. This integration is designed to be transparent to your application logic. You continue to use familiar SQS APIs, while the client handles the complexity of splitting, uploading, and downloading messages behind the scenes. This helps maintain cleaner code and better developer experience. Offloading payloads to S3 also keeps your SQS messages lightweight and efficient. It reduces payload size within the queue, allowing you to stay well within service quotas and optimize performance, especially when queues are moving at high throughput. The client is configurable. You can set a custom message size threshold so that only messages above a certain size are stored in S3, while smaller ones continue to be sent directly through SQS. While this approach adds some latency and cost overhead due to the S3 interactions, it's a powerful way to extend the capabilities of SQS when working with larger data formats in enterprise or data-intensive workflows. Importantly, the extended client supports both sending and receiving workflows. It uploads large payloads to S3 during send operations and retrieves them on the receiving end automatically. This allows for complete end-to-end lifecycle management of large messages without any manual intervention. A dead letter queue, or DLQ, is a specialized type of SQS queue designed to handle messages that simply can't be processed successfully, no matter how many times they're retried. These messages, often called poison messages, may be malformed, cause processing errors, or trigger exceptions that prevent the consumer from completing its work. Rather than allowing these problematic messages to endlessly cycle through retries, consuming resources, and potentially blocking other valid messages, SQS moves them into a dead letter queue once they exceed a set number of delivery attempts. This segregates the failures from the main queue, allowing your primary workflow to remain healthy and responsive. This design dramatically improves fault isolation. It ensures that transient or persistent issues tied to specific messages don't degrade overall system performance or impact the availability of your consumers. One of the biggest advantages of a DLQ is the controlled, observable space it provides for debugging and analysis. Once messages land in a DLQ, developers and operators can examine them without pressure, identifying the root causes of failure, validating assumptions, and deploying targeted fixes. DLQs also support manual or automated reprocessing. After resolving the underlying issue, whether it's a data formatting problem, an unavailable downstream dependency, or a code bug, you can reintroduce the messages back into the primary queue or route them through a different recovery path. It's important to remember that DLQs are not enabled by default. You'll need to explicitly configure and associate one with each source queue you want protected. DLQs work with both standard and FIFO queues, but the types must match. A FIFO source queue requires a FIFO DLQ, and the same applies for standard queues. Amazon SQS is inherently scalable and reliable, but there are several key strategies you can apply to maximize its efficiency and fault tolerance, especially in high throughput or mission-critical environments. First, always consider enabling long polling instead of relying on short polling. Long polling allows your consumers to wait for a message to arrive for up to 20 seconds, significantly reducing empty responses and unnecessary API calls. This results in lower costs and more responsive consumers. Another important practice is to use batch operations. SQS supports sending and receiving messages in batches of up to 10. This reduces the number of API calls, increases throughput, and leads to better cost and network efficiency, particularly in systems processing hundreds or thousands of messages per second. The visibility timeout setting is also a critical tuning lever. This determines how long a message stays hidden from other consumers while it's being processed. Set this too short, and a message might be delivered to another consumer before processing is complete. Set it too long, and failures delay retries. Tuning this value based on your processing time is essential for maintaining throughput and consistency. And just as important, Always design your consumers to be idempotent. That means they can safely handle the same message more than once. While SQS guarantees at least once delivery, occasional duplicates can occur, so consumer logic must gracefully handle them. If your application depends on strict message ordering or exactly once processing, use FIFO queues. They ensure a message is processed only once and in the exact order it was sent, providing greater reliability for workflows where sequence integrity is paramount. Finally, incorporating dead letter queues adds a valuable safety net. They ensure messages that are not processable get automatically isolated after repeated failures, preventing them from clogging the main queue and allowing developers to inspect and recover from errors without impacting live traffic. To start, server-side encryption, or SSE, enables SQS to encrypt message contents at rest using AWS Key Management Service, KMS. This helps ensure that sensitive information, such as customer records, financial data, or health information, is protected while stored in SQS. All communication with SQS is protected in transit using TLS, Transport Layer Security. This safeguards messages against interception or tampering as they move between producers, consumers, and the queue. Access control is enforced through AWS Identity and Access Management, or IAM. With IAM, you can apply fine-grained policies that govern who can send, receive, or manage messages. This enforces the principle of least privilege and ensures only authorized users and services interact with your queues. For secure connectivity, you can use VPC endpoints powered by AWS Private Link. This allows your applications inside a virtual private cloud to connect to SQS without traversing the public internet, reducing exposure and enhancing network-level security. From a governance standpoint, AWS CloudTrail integrates with SQS to provide detailed logs of all API activity, including who accessed the queue, when, and what operations they performed. These logs are crucial for auditing, monitoring, and incident response. Finally, Amazon SQS is compliant with major industry regulations and certifications, including HIPAA, PCI DSS, SOC 1, 2, and 3. This means SQS can be safely used in regulated industries such as healthcare, finance, and government. Amazon SQS follows a pay-as-you-go pricing model. That means you're charged based on the number of requests your application makes, including calls like send message, receive message, and delete message. This makes costs highly predictable and directly tied to usage patterns. To help you get started or support smaller workloads, SQS also offers a monthly free tier of 1 million requests. This is incredibly useful for development environments, low-traffic applications, or simply for testing and experimentation without incurring costs. You can further optimize your spending by using batch operations. SQS allows you to send or receive up to 10 messages in a single batch request. This dramatically improves efficiency and reduces the cost per message, especially in high-throughput systems. Now it's important to understand that not all queues are priced the same. FIFO queues, which preserve the exact order of messages and guarantee exactly once processing, cost more than standard queues. This is due to the additional processing required to enforce ordering and deduplication semantics. Another pricing consideration is message size. Charges are based on 64 kilobyte chunks. So if you send a 256 kilobytes message, you're billed for 4 request units. Keeping message sizes lean can help keep costs down. Lastly, keep in mind that long polling, while more efficient for reducing empty responses, still incurs request charges. Similarly, if you're using the SQS Extended Client Library to store large payloads in Amazon S3, you'll incur additional S3 costs for both storage and data retrieval. At the heart of SQS monitoring is Amazon CloudWatch integration. Out of the box, SQS emits a rich set of metrics to CloudWatch. These include operational metrics like number of messages sent, number of messages received, and approximate number of messages delayed, giving you real-time visibility into how your queue is behaving. These metrics can be used to closely monitor queue depth and processing lag. For example, approximate number of messages visible tells you how many messages are waiting to be processed, while approximate number of messages not visible can indicate messages in flight or being processed. If these numbers are consistently high, it may signal that consumers are overwhelmed or under-provisioned. Another key metric, approximate age of oldest message, helps detect stale or unprocessed messages, a strong indicator that something might be broken downstream. You can also keep an eye on your dead letter queues. By tracking the rate at which messages land in a DL queue, you can quickly catch systemic issues like malformed messages, logic errors, or unavailable dependencies in your consumers. For proactive response, CloudWatch alarms can be configured on any of these metrics. Whether you want to trigger an auto-scaling action, invoke a Lambda function, or simply send an alert to your ops team, alarms make it easy to automate your response to performance anomalies. In addition to metrics, AWS CloudTrail logs all SQS API actions. This provides a robust audit trail, critical for compliance, troubleshooting, and security investigations. Finally, while Amazon SQS does not natively integrate with AWS X-Ray, producers and consumers can be instrumented with X-Ray. This allows you to trace message flows and identify latency hotspots, giving you end-to-end visibility across your system. When evaluating Amazon SQS and Amazon Kinesis data streams, it's important to understand that while both are messaging services, they're architected for different data movement patterns and application needs. Amazon SQS is a fully managed message queuing service that enables the decoupling of microservices, distributed systems, and serverless applications. It's designed for reliability, simplicity, and scalability. With standard queues, you get high throughput and at least once delivery, while FIFO queues add ordering and exactly once processing guarantees, perfect for payment systems, workflows, and job coordination. On the other hand, Amazon Kinesis Data Streams is purpose-built for real-time streaming data. It's ideal when you're ingesting and processing time series data, like application logs, click streams, sensor data, or telemetry. Kinesis supports multiple consumers reading from the same stream simultaneously, and data is retained for up to 7 days, enabling replay for error recovery or new consumers. SQS uses a polling model, where consumers pull messages using short or long polling. Kinesis, in contrast, supports both pull and enhanced fanout models through the Kinesis client library, enabling near real-time data delivery to multiple consumers with minimal latency. While SQS automatically scales, Kinesis requires manual sharding. Each shard in a Kinesis stream provides a fixed throughput and must be managed according to your traffic patterns. This gives Kinesis more predictable performance, but demands greater operational oversight. SQS supports messages up to 256 kbytes, while Kinesis records can be up to 1 megabytes, which suits high-volume log ingestion and rich event payloads. From a cost standpoint, SQS is priced per request and includes a free tier, whereas Kinesis pricing is based on shard hours and payload units, which can be more expensive at scale but offers greater control and flexibility. Lastly, SQS doesn't support replay once a message is processed or expired, but Kinesis allows consumers to replay data for analytics, debugging, or recovery workflows, a crucial feature for event-driven architectures. In summary, use SQS for decoupling services and asynchronous communication in transactional systems, and choose Kinesis when you need real-time analytics, replayability, and high-throughput stream processing across multiple consumers. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.